if x of n is a real signal having the DTFT x of e power j omega, then find the DTFTs of the sequences given below in terms of x of e power j omega. First one, y of n equals x of minus n. Second one, g of n equals x of n convoluted with x of minus n. Third one, s of n equals minus 1 to the power n into x of n. Fourth one, z of n equals 1 plus cos n pi into x of n. And fifth one, b of n equals minus 1 to the power n by 2 into x of n. Solution. Y of n equals x of minus n. Reflection in time corresponds to reflection frequency. Therefore, what is y of e power j omega? Y of e power j omega is nothing but x of e power minus j omega. This is the answer. Second one, applying convolution property. We get convolution property. What it says is time domain convolution is transformed into frequency domain multiplication. We get g of e power j omega is equal to, what is DTFT of x of n? X of e power j omega. Convolution becomes multiplication. What is DTFT of x of minus n? From previous part, it is x of e power minus j omega. Since x of n is a real signal, x of e power minus j omega is equal to x conjugate of e power j omega. Hence, g of e power j omega is equal to x of e power j omega into x conjugate of e power j omega equals modulus of x of e power j omega whole square. Third one, s of n is equal to minus 1 to the power n into x of n. Minus 1 is what? E to the power j pi. This becomes what? E to the power j times pi n into x of n. Because minus 1 equals e to the power j pi. Applying frequency shift property. We get s of e power j omega is equal to x of e power j. Omega gets replaced by omega minus pi. X of e to the power j omega minus pi. This is because of frequency shift property. X of n is what? What is s of n? E to the power j pi n into x of n. If x of n is multiplied by e to the power j pi n, in x of e power j omega, omega will get replaced by omega minus pi. Fourth one, z of n is equal to 1 plus cos n pi into x of n. Cos n pi is what? Cos n pi is minus 1 to the power n. into x of n. This I can remove the brackets. X of n minus 1 to the power n minus 1 to the power n. I'll write as e to the power j pi n into x of n. Applying frequency shift. Applying frequency shift and linearity properties. We get z of e power j omega is equal to x of e power j omega plus x of e to the power j. Omega will get replaced by omega minus pi. This is the answer. Fifth one, b of n equals minus 1 to the power n by 2 into x of n. This can written as e to the power j times pi by 2 into n into x of n, because minus 1 is e to the power j pi. Again applying frequency shift property. Applying frequency shift property, we get b of e power j omega equals, when you take DTFT, you should always write capital letter. When you write a time domain signal, you should write a lowercase letter or a small letter. So this is x of e to the power j omega minus pi by 2. So this is the end of the solution. Find the DTFT of x of n equals cos of 0.2 pi n plus pi by 4. Also sketch amplitude and phase spectra. Very important problem. Amplitude and phase spectra. Solution. Recall cos theta is equal to what? Half into e to the power j theta plus half into e to the power minus j theta. Now what is theta in this context? 0.2 pi n plus pi by 4. Hence x of n equals half into e to the power j times 0.2 pi n plus pi by 4 plus half into e to the power minus j 0.2 pi n plus pi by 4. This I can write as half into e to the power j times pi by 0.2 pi n plus half into e to the power minus j pi by 4 into e to the power minus j 0.2 pi n. Recall a constant a has a discrete time Fourier transform 2 pi a into delta of e power j omega. For the sake of convenience, delta of e power j omega I will replace by delta of omega. Delta of e power j omega is same as delta of omega. This form is very crucial to get the location. If somebody asks what is the location of this impulse, it is easy to say by looking at this. What is the quantity inside the brackets? Omega. Put it to 0. Therefore, this impulse will occur at omega equal to 0. Delta of e power j omega is same as delta of omega. Write a note here. Delta of e power j omega is same as delta of omega. Please don't think e to the power j omega is replaced by omega. Hence, x1 of n equal to, I take this as x1 of n. X means I put a is equal to half into e to the power j times pi by 4. And this I will take it as x2 of n. This I will take it as x2 of n. And this I will take it as x1 of n. x1 of n equal to half into e to the power j pi by 4 will have a discrete time Fourier transform. Discrete time Fourier transform. x1 of e power j omega is equal to 2 pi. What is a? A is what? Half into e to the power j times pi by 4 into delta of omega. So this becomes now pi into e to the power j times pi by 4 into delta of omega. And x2 of n is equal to half into e to the power minus j pi by 4 will have a discrete time Fourier transform x2 of e power j omega equals 2 pi. Now what is a? A is nothing but half into e to the power minus j pi by 4 into delta of omega equal to pi into e to the power minus j pi by 4 into delta of omega. Next I will apply frequency shift property. Applying frequency shift property. Applying frequency shift property we get. Please watch. This whole thing I will call as x3 of n. This whole thing I will call it as x4 of n. Applying frequency shift property we get x3 of n is equal to x1 of n multiplied by e to the power j times 0.2 pi n will have a discrete time Fourier transform x3 of e power j omega is equal to x1 of e to the power j. Omega gets replaced by omega minus 0.2 pi equal to what is x1 of e power j omega? This is the expression. Replace in this expression omega by omega minus pi by 4. So you get pi into e to the power j times pi by 4 into delta of omega minus 0.2 pi. And x4 of n. What is x4 of n? x2 of n into e to the power minus j 0.2 pi n will have a discrete time Fourier transform x4 of e power j omega is equal to x2 of e to the power j omega plus 0.2 pi equal to pi into e to the power minus j pi by 4 into delta of omega plus 0.2 pi. Next we have to apply linearity property. Applying linearity property we get. What is x of n? X of n is x3 of n plus x4 of n will have a discrete time Fourier transform x of e power j omega equal to x3 of e power j omega plus x4 of e power j omega. That means it is pi into e to the power j times pi by 4 delta omega minus 0.2 pi plus pi into e to the power minus j pi by 4 delta of omega plus 0.2 pi. Now I am going to sketch the amplitude spectrum or magnitude spectrum, both mean the same. Magnitude bar amplitude, both mean the same spectrum. To get that, what I have to do? I have to take magnitude of x of e power j omega. What is magnitude of x of e power j omega? Magnitude of pi into e to the power j pi by 4. Magnitude of this exponential e to the power j pi by 4 is 1. So this is nothing but modulus of pi into modulus of e to the power j pi by 4. Modulus of this exponential is 1. Because e to the power j theta is cos theta plus j sin theta. What is magnitude of e to the power j theta? Square root of cos square theta plus sin square theta, which is 1. In this case, theta is pi by 4. This is pi. And where does this occur? Given by the quantity inside the brackets of this impulse function equated to 0. Omega minus 0.2 pi equated to 0 gives you omega equal to 0.2 pi. That means at omega equal to 0.2 pi, you have an impulse whose strength is pi. Then I will take the magnitude of this gives the, for finding the magnitude use this term, for finding the location use the impulse term. So what you get? Modulus of pi into e to the power minus j pi by 4 equals modulus of pi into modulus of e to the power minus j pi by 4 is equal to pi when omega is minus 0.2 pi. Please note, I made use of the expression e to the power plus minus j theta is 1 at an angle plus minus theta. That means this exponential e to the power plus j pi by 4 and the exponential e to the power minus j pi by 4 will have a magnitude equal to 1. Angle will be plus theta for this one, minus theta for the other one. What is phase spectrum? Phase spectrum, theta of omega equals. We have to find this impulse gives only location. Angle of pi into e to the power minus j pi by 4. It's nothing but angle of pi plus angle of e to the power minus j pi by 4. Pi means 3.1 for a real number. So what is its angle? 0. What is the angle of this exponential? Minus pi by 4. Sorry, plus pi by 4. Sorry, plus pi by 4. This is at omega equal to 0.2 pi. I've taken this term. This term I took for finding magnitude here, for finding angle over here. Then this term I will take. Angle of, this is plus pi into e to the power minus j pi by 4 equals angle of pi plus angle of e to the power minus j pi by 4. Angle of 0, pi is 0. Angle of this exponential is minus pi by 4. This occurs at omega equal to minus 0.2 pi. Now I get the magnitude spectrum and the phase spectrum. Please watch. First I will draw the magnitude spectrum. X-axis is omega. Y-axis is magnitude of x of e power j omega. This is minus pi. This is plus pi. This is 0.2 pi. This is minus 0.2 pi. At plus 0.2 pi, what is the strength of the impulse? Strength of the impulse is pi. Please note that this spectrum exhibits even symmetry. This spectrum exhibits even symmetry. There are only two impulses occurring at minus 0.2 pi and plus 0.2 pi. This spectrum has gone only for one period of x of e power j omega. Next I will go to phase spectrum. Phase spectrum must exhibit arc symmetry. X-axis is omega, y-axis is theta omega. This is minus pi, this is plus pi. This is minus 0.2 pi, this is plus 0.2 pi. At plus 0.2 pi, what is the angle? pi by 4. So we have an impulse representing pi by 4, and at minus 0.2 pi and at minus 0.2 pi we have an impulse whose strength is minus pi by 4. This is phase spectrum which exhibits odd symmetry. This is amplitude spectrum which exhibits even symmetry. Both the spectra are drawn for one period of x of e power j omega. Hence we have shown from these two figures between minus pi to plus pi. Find inverse DTFT of x of e power j omega h of e power j omega equal to 1 plus 2 times cos omega plus 3 by 2 times 1 plus cos 2 omega. Solution. Cos theta is what? E to the power j theta plus e to the power minus j theta by 2. Euler's formula. H of e power j omega I can write as 1 plus 2 times e to the power j omega plus e to the power minus j omega divided by 2 plus 3 by 2 into 1 plus half into e to the power j times 2 omega plus e to the power minus j times 2 omega equals 1 plus e power j omega plus e power minus j omega plus 3 by 2 plus 3 by 4 into e power j times 2 omega plus 3 by 4 into e power minus j 2 omega. I'll write this in the most negative exponential to most positive exponential. I'll rearrange this expression. So I write 3 by 4 into e power minus j 2 omega plus e power minus j omega. 1 plus 3 by 2 is what? 5 by 2. 5 by 2 plus e power j omega plus 3 by 4 e to the power j times 2 omega. I call this as equation 1. We know that h of e power j omega is equal to summation n equals minus infinity to plus infinity h of n into e to the power minus j omega n. When n is minus 2, what is the term in this? What will be the term the summation gives? H of minus 2 into e power j times 2 omega. E to the power when n is let us say when n is 2. What will be the power of the exponential? E power minus j 2 omega. When n is minus 2, what will be the term? This will be the term. So comparing 1 and 2, I repeat again. This summation, if you expand, we'll understand better. When n is minus 2, what you get? H of minus 2 e to the power j times 2 omega. When n is minus 1, what you get? H of minus 1 into e to the power minus j omega plus omega. When n is 0, you get h of 0. When n is 1, you get what? H of 1 into h of 1 into e to the power minus j omega. When n is 2, you get h of 2 into e to the power minus j omega and dash dash. This you call as equation 2. Comparing 1 and 2, you will find h of minus 2. What is h of minus 2? H of minus 2 is 3 by 4. What is h of minus 1? Coefficient of e power j omega, which is 1. What is h of 0? 5 by 2. What is the coefficient of e power minus j omega? H of 1. What is the coefficient of e power minus j omega? It is 1. Therefore, h of 1 should be 1. If you comparing 1 and 2, we get h of n is equal to 3 by 4 1, 3 by 4, 1, 5 by 2, 1, 3 by 4. This is the index error. This is for n varying from -2 to +2. This is h of 0, which is 5 by 2. This is h of 1. What is h of 1? H of 1 is what? Coefficient of e power minus j omega, which is 1. And what is this? This is nothing but h of -2. H of -2 means it is coefficient of e power j times 2 omega, which is 3 by 4. I think the problem is well understood, right? Cos theta as e power j theta plus e power minus j theta by 2. Then get the expression in terms of exponentials. Then write the defining equation for finding DTFT of h of n. Correct? Compare the two equations. Please note that coefficient, this term occurs when n is -2. This term occurs when n is -1. This term occurs when n is 0. This term occurs when n is 1. This term occurs when n is 2. Now compare, this is the result we get.